In this example, we're going to solve this quadratic equation, and we're going to do so by using the quadratic formula. So the first thing I notice is that we have our quadratic expression here in standard form, and it equals 0. So let's go ahead and grab our values for a, b, and c, and then we can plug them in. So a is going to be the leading coefficient, so 1. b is going to be the coefficient of our linear term, so negative 4. And c is going to be our constant, which is 13. Okay, so let's go ahead and plug some values in. X equals the opposite of b. Well, the opposite of negative 4 is positive 4, plus or minus the square root. Now b squared, so negative 4 squared is 16, minus 4 times a times c, all over twice a. Okay, so x equals, we have 4 plus or minus the square root of 16 minus, and 4 times 1 times 13 is 52, all over 2. So shuffling over, we have 4 plus or minus the square root of negative 36. And we see that the square root of a negative here will ultimately give us complex solutions. So 4 plus or minus, so I can break this up as the square root of negative 1 times the square root of 36. And the square root of 36 is 6, and this negative 1 will give us the I, all over 2. So let's go ahead and finish up. I can factor a 2 out of each of these terms in an effort to cancel this 2. So let's go ahead and see what that looks like. So 2 plus or minus 3i all over 2. And indeed, those 2's cancel. So I'm left now with x equals 2 plus or minus 3i. And in a lot of cases, we want to separate these two solutions out because we want them to be in a plus bi form. So I'll say x equals 2 plus 3i and 2 minus 3i because we like to see them separated. So there are the two complex roots or solutions for this original quadratic equation.